Chapter 13, Galaxies. Now, if you see a picture like this, and it is labeled the Milky Way galaxy, it is a lie. No such picture exists. We can't even go to our next door neighbor star 4 light years away, let alone pop out 100,000 light years to take a galactic selfie. That doesn't exist. When we see the Milky Way in the sky, now this is a picture that I took in Peru, one of the better Milky Way shots that I have, which isn't saying too much, but it looks like a line in the sky. That's where the Greeks got the name, the Milky Way, this white path in the sky. And the reason it's a flat path is because we live in a flat galaxy, but we're only seeing a small portion of our galaxy. We're kind of looking downtown when we see this in really dark locations. Here's a beautiful shot someone took of the Milky Way. But again, that's kind of looking downtown within our own galaxy. We have trouble actually studying our galaxy because we are within it. We know a lot more about more distant galaxies, millions and billions of light years away, than our own galaxy, which is kind of interesting. What is a galaxy? Well, I'll usually refer to it as a city of stars. Now, to be fair, there's a lot more than just stars. That's what we think of because that's what we see with our eyes. But you have a lot of dust and gas. You have what we call dark matter. There's a lot more to a galaxy than just the stars, but they kind of define the galaxy in our mind because, again, that's what we see. Our own galaxy, the Milky Way, can be thought of as 3 distinct regions. The disk is the part we're most interested in, mainly because that's where we live, and also because it's the part of our galaxy that contains the most dust and gas, and that's what's going to create new stars in places like the Orion Nebula and the Pillars of Creation and so forth. That's the disk. As you can see from the picture at the bottom of the screen, towards the middle of our galaxy, it bulges outward. So that is cleverly called the galactic bulge. And 2 things to note here from this picture. You see the Earth way out here in the galactic disk. So yet again, we get our feelings hurt. First, we found out we're not the center of our solar system. And later, we find out that our solar system is nowhere close to being the center of our galaxy. We are way out in the suburbs of our city. Also, this is a great picture to show the issue that we have trying to study the center of our galaxy. We are looking right through a lane of dust and gas, and that's going to present a problem. Finally, the third area often gets ignored because it is invisible, literally invisible, the galactic halo. It is spherical, unlike the flat frisbee shape of our galaxy that we normally think of. This spherical area does exist, but it contains things that we can't see. Faint stars, and everything else is grouped together in what we just call dark matter. That's not necessarily some kind of exotic thing. It just is material that we can't see for whatever reason. Later in the chapter, we'll talk about some ideas on what dark matter may be. But for now, you see in this picture here, it's kind of funny from a textbook, where a galactic halo, well, they just point to a random point on the screen because you can't see it, but it's spherical. We'll talk more about it in just a second. Here is the latest version of what we think our Milky Way galaxy looks like. And unfortunately, we don't know for sure. We're still adjusting this. We've made changes even since I've been a teacher as we learn more. So you see going out from the center, 10,000, 20,000, almost 30,000 light years away, about 28,000 light years away is our solar system. And we live in a little area here called the local arm. Sometimes it's called the Orion spur or the Orion arm. That's our little section. And when we saw that picture a few minutes ago that I took in Peru, anytime you're somewhere really, really dark where you can see the Milky Way, actually, most of what you're seeing is right here. If you look at the screen, you're just really looking over and seeing the next arm of the Milky Way. You're not even seeing the vast majority of our galaxy, just that next arm over. Okay, I call this section Stars on the Galactic Carousel. because much like horses going around on a carousel, even though we're going around on a fairly flat disk of our galaxy, stars do tend to kind of bob up and down a little bit as they gravitationally affect each other. Younger stars are sometimes called population 1 stars. Older stars, and we said again, the galactic disk is where most young stars are located. Older stars, at least used to be called population 2 stars, are found more in the bulge and the halo areas. So, how long does it take us to go around this carousel, around the center of our galaxy? Well, a galactic year is almost 250 million years old. So 225 million years or so to make one trip, one orbit around our galaxy. Since the sun is 4.5 billion years old, that means that the sun is actually about roughly 18 galactic years old, the same age as my students. Old enough to vote, not old enough to drink. Although it has been seen with a corona. Okay, sorry, I had to do it. Next section, the formation of the Milky Way. We now know that there's actually more than one disk. There's not just a single disk. There's kind of a thinner disk and a thicker disk. That's something that's kind of new, along with the halo and the bulge. But mainly what you need to know here is that the galaxy apparently started out spherical and then flattened out later. And so the spherical part remained, and that's called the halo today. And then, of course, we have the disk where we live. Conservation of angular momentum, when something is spinning, what I like to call the law of pizza dough, makes it flatten out. And so that's what's happened to our galaxy. It's very, very analogous to what happened to our solar system. Our solar system formed from a spherical nebula. Most of it flattened out, and that became the planets, and it became the Kuiper Belt. But there's this leftover remnant, this leftover debris out there called the Oort cloud. These dirty snowballs that eventually form long-period comets when they get kicked in towards the sun, that is the remnant of when we were still spherical, much the same way that the halo is the remnant of when our galaxy was spherical, before it flattened out. Kind of interesting stuff. Finally, the center of our galaxy, again, is blocked by a lot of dust. So it doesn't do you a lot of good to use the Hubble telescope or the Keck in Hawaii or the VLT in Chile, because they're just going to see the next arm of dust, and that's it. They get blocked. So we have to use long wavelength radiation, such as infrared and radio. So if you want to study the center of our galaxy, you really need to be a radio astronomer and use radio dishes to do so. So what have we learned about the center of our galaxy through radio? Well, one thing we've learned is that it's much denser than our suburban area of the galaxy. Many more stars per cubic light year. Actually, if you live there on a planet, you might not even really have a true nighttime, because even when you spun away from your star, there might be so many bright stars in the sky that it would still be light out, even when it's supposed to be nighttime. Actually, so many stars, in fact, and so much intense radiation that life as we know it may not be able to exist too close to the center of our galaxy because of that, because of the high intensity radiation. Now, maybe life has evolved there that's a hardier type of life than we have here. We just don't know. Finally, we've already mentioned that at the very, very center of our galaxy is a supermassive black hole. We now think it's just over 3 million solar masses. Let that sink in. It weighs 3 million times more than our sun. Now, having said that, let me make 2 points. Point number one, that's actually pretty weak for a supermassive black hole, especially for a galaxy our size. I think the current heavyweight champion of supermassive black holes weighs 12 billion solar masses. So ours is really dinky compared to that. And point number two, compared to the size, this supermassive black hole might be roughly the size of our solar system. But compared to the size of our galaxy, that makes it kind of like 1 grain of sand in a swimming pool full of sand. I mean, it's really a small area, volume-wise, it's very small, very, very small compared to the size of our whole galaxy. But it is important, and that is what we orbit as we go around our galaxy. It even has a name. We call it Sagittarius A. I assume it was probably discovered long before it was known that it was a supermassive black hole. It was a radio source just simply called Sagittarius A, being found in the direction of the constellation Sagittarius. So if you see Sagittarius from here in South Florida, in the summer night sky towards the south, you're looking towards the center of our beautiful spiral galaxy, the Milky Way. Thanks for listening.